All right, so here we go. We have a car driving down the road in cruise control. While a car drives down the road in cruise control, it means it has a constant velocity. Now, Isaac Newton tells us that an object at constant velocity will always stay at that velocity. You don't need to push it to keep it moving at the constant velocity. It will simply stay at that velocity unless an outside force is acting on it. So while you're driving down the road at a constant velocity with your cruise control on, your car would stay at that velocity if there was no other forces acting on it. In other words, in a perfect world, once you got up to a certain velocity, you could turn your car off and it would continue at that velocity forever. But we know that there is an outside force of air resistance. Air resistance is simply the collision with air particles, and it slows a car down. So while you're in cruise control, air resistance is a constant force slowing you down, so your engine must match that constant force in order for you to drive at a constant velocity, in order for your net force to equal 0. So let's look at this problem. It gives a lot of information, some of it is not needed. It says when a car drives down the road at 30 miles per hour, the force is 450 newtons. But when it speeds up, the force of air resistance increases, which makes sense. You're moving faster. All right? But then it says, the question says when the car its cruise control is on and it's set to 30 miles per hour. So we know when it's 30 miles per hour, there's 450 newtons of force. How much force does the engine need to apply to the car to keep moving at a constant velocity, to make sure there's no acceleration, either negative or positive acceleration, to simply keep the net force on the car to be 0? Well, let's look at this problem. In this problem, the relevant information is that the force of air is equal to 450 newtons when the velocity is 30 miles per hour. All right, the other information is not needed because the question doesn't talk anything about moving 65 miles per hour. So in this problem, we need to set up a net force equation, a free body diagram, and write the givens. So let's do that. Let's draw a free body diagram. Here's a dot representing the car. It's the system. On this dot, there's a force to the right, which represents the force of the air resistance. There's a force to the left, which represents the force of the car, or the force of the engines pushing the car. Now, if we want this car to neither be speeding up or slowing down, what do we want the acceleration to be, or what should the acceleration be? The acceleration should be 0 meters per second squared, because the problem says when the car's cruise control is on. When you're in cruise control, you have 0 acceleration. All right? And if you have 0 acceleration, what does that mean about your net force? Well, net force equals m times a, so you're going to have a 0 net force. So that means that the force of the car must equal the force of the air resistance. So when we make this equation, the net force is equal to the force of the car plus the force of the air resistance. We know the net force is equal to 0 newtons. First step. Second step. The force of the car is unknown, plus the force of the air. Well, we know that that is 450 newtons. Solving for the force of the car, we bring the 450 to the other side. It becomes negative 450 newtons equals the force of the car. So that means the force of the car must be pushing with 450 newtons to the left to cancel out the air resistance pushing to the right. And if those forces are equal, if they're balanced, then the car will be in equilibrium and it will not be accelerating.